In the first part of calculus, we discussed extensively the properties and processes of differentiation and integration. In the second part, we will start by discussing the applications of integration. So to begin with, let us start by reviewing some basic differentiation and integration rules. For example, the derivative of u to the power of n with respect to x. Remember, u is a function of x, like say 2x plus 1 or sine x and so on. So the derivative of u to the power of n with respect to x is n u to the power of n minus 1 times the derivative of u with respect to x. For example, what is the derivative of sine cube x with respect to x? It will be 3 sine squared x times the derivative of sine x, which is cos x. Alright, therefore, what is integral of u to the power of n du? It will be u to the power of n plus 1 over n plus 1 plus c. Another one, the derivative of sine u with respect to x is cos u times the derivative of u with respect to x. For example, the derivative of sine of 5x is cos of 5x times the derivative of 5x with respect to x is 5. So, derivative of sine 5x is 5 cos 5x. And therefore, what is integral of cos u du? Integral of cos u du will be sine u plus c. Alright? The derivative of cos u with respect to x is negative sine u times u prime, and therefore integral of sine u du is negative cos u plus c. Alright? The derivative of tan u with respect to x is secant squared u times the derivative of u with respect to x. And therefore, what is integral of secant squared u du? It must be tan u plus c. The derivative of a over u equal to negative a over u squared u prime. You see that? The derivative of a over x is negative a over x squared. Therefore, what is integral of negative a over u squared du? It will be a over u plus c. Or integral of a over u squared du will be negative a over u plus c. Now finally, the derivative of ln u equal to 1 over u times u prime. Therefore, if you integrate 1 over u with respect to u, integral a over u du will be a ln u plus c. Now, you must be very familiar with these integration rules in order to proceed into our second part of this course. Alright, so maybe write them down and learn. That's the best way to learn these. Alright, let's talk about definite integral. What is a definite integral? In other words, what does this represent? Integral a to b f of x dx. What is the physical meaning of that? Well, the physical meaning of this is integral a to b f of x dx is a measure of the area enclosed by the graph of f of x with the x-axis. That's right. It represents the area enclosed by the graph of f of x with the x-axis from x equal to a to x equal to b. That's why it's called a definite integral. Now, suppose we have, this is the function of x, f of x, and this is x equal to a, and this is x equal to b. Now, shade that area. This area is actually given by this definite integral. So the meaning of integral a to b, integral a to b f of x dx represents the area enclosed by the graph of f of x with the x-axis from x equal to a to x equal to b. And that must be very, very clear, and we will be using this as we move on. Alright, that leads us to the concept of area of a region between two curves. Now, let's talk about this. What does integral 0 to 6 x squared minus 6x dx represent? Well, as we said earlier, it will represent the area enclosed by the graph of this function. Your f of x is x squared minus 6x. If you draw the graph of this and measure the area enclosed by the graph of this with the x-axis from x equal to 0 to x equal to 6, that will be a measure of that definite integral. So what is the physical meaning of this statement? This definite integral represents the area enclosed by the graph of f of x equal to x squared minus 6x and f of x equal to 0. Remember, f of x equal to 0 is the x-axis, y equal to 0, between x equal to 0 and x equal to 6. Now, if you look at this, this is the graph of x squared minus 6x. And it cuts the x-axis at x equal to 0 and x equal to 6. And all that area is below the x-axis. Is that right? Yes. So, is this area a positive or a negative quantity? All of this area, the area enclosed by the graph of this function, with the x-axis from x equal to 0 to x equal to 6, is below the x-axis. It means that this is a negative quantity. The area enclosed by the graph of a function with the x-axis, if the area is below the x-axis, that is a negative quantity. If the area is above the x-axis, it is a positive quantity. Now, let's do this now. You know how to integrate this quantity. Integral x squared is x cubed over 3, x to the power of n plus 1 over n plus 1, x to the power of 2 plus 1 over 2 plus 1, minus 6 times what is integral of x dx. It will be x squared over 2. Now, this quantity is now measured from x equal to 0 to x equal to 6. The lower limit is 0, the upper limit is 6. Now, how do we find the value of this? First, replace x by the upper limit. So, we have x cubed is replaced by 6 cubed. So, that will be 6 cubed over 3 minus 6 times 6 squared over 2. So we have now used the upper limit. Now minus, now use the lower limit. But when you use the lower limit x equal to 0, both these quantities become 0. So that will be 0. So you have the upper limit value minus the lower limit value. Now simplify this. You don't need my help to do that. That will be negative 36 square units is that area. That means the value of this definite integral is negative 36 square units. The area enclosed by the graph of this with the x-axis from x equal to 0 to x equal to 6 is a negative quantity. The area is below the x-axis. All right. Let's talk about this now. What definite integral represent the shaded area in here? Now here, if you notice, the shaded area is actually the area enclosed by the graphs of two functions. Now, the straight line represents the function g of x equal to 2x plus 5. And the parabola is the function f of x equal to x squared plus 2x plus 1. Now, look at the 2 points where they meet. They meet at x equal to -2 and at x equal to 2. That means this area is a measure of the area enclosed between g of x and f of x from x equal to -2 and x equal to 2. Right? So, this is the area enclosed by the graph of g of x equal to 2x plus 5 and f of x equal to x squared plus 2x plus 1. In fact, I don't even need to mention the limits because the area enclosed by these two graphs exists only between these two x values. So, the boundaries of this area are the points of intersection of the two curves. Now, how do you find the points of intersection? The point of intersection occurs where these two function values are equal. So what all we need to do is set f of x equal to g of x and solve for x. So this is our f of x and this is our g of x. Set it equal to 0. Set them equal to each other. Is that right? Where they intersect, the functions are equal to each other. Now, solve this equation. Now, follow these steps. I just moved these terms to the left. And now, combine terms. That gives you x squared minus 4 equal to 0, which is x minus 2 times x plus 2 equal to 0. Gives you x equal to 2 is one value, and x equal to -2 is the other value. That means one point where they intersect is x equal to -2, the point corresponding to x equal to -2, and the other is x equal to 2. Therefore, this is the area enclosed by the graph of g of x equal to 2x plus 5 and f of x equal to x squared plus 2x plus 1 between x equal to -2 and x equal to 2. Can you write this area as a definite integral? I'm going to leave it for you. Alright. The area enclosed by the graph of g of x equal to 2x plus 5 from x equal to 2 to x equal to, from x equal to -2 to x equal to 2. Can you write this as a definite integral? Now this is one of the functions we just talked about earlier. G of x equal to 2x plus 5. Now what is the area enclosed by this from x equal to -2 to x equal to 2? What definite integral represent that? Well, that will be integral -2 to 2 of 2x plus 5 dx. And that is a measure of this area. In other words, the area enclosed by g of x with the x-axis. That's right. And is given by integral -2 to 2, 2x plus 5 dx. That's right. This is a measure of the area enclosed by g of x equal to 2x plus 5 with the x-axis. Now, let's take the other function, f of x equal to x squared plus 2x plus 1. And look at that area. The area enclosed by f of x equal to x squared plus 2x plus 1 from x equal to -2 to x equal to 2 is this definite integral. And this is a measure of the area enclosed by the graph of f of x with the x-axis from x equal to -2 to x equal to 2. And now, earlier we found that the area enclosed by these two graphs, we saw that area. Now how do you get that area? How do you get the area enclosed by the graph of g of x and f of x? What we know here is that this definite integral gives you the area enclosed by the graph of this function with the x-axis. And this definite integral gives you the area enclosed by the graph of this function, f of x, with the x-axis. Alright. Now, here we have the area enclosed by the graph of g of x and f of x. Now, if you notice, there is a very simple way to obtain that area. The area enclosed by the top curve with the x-axis, if you remember, the area enclosed by the top curve with the x-axis is all this area. All this area. And the area enclosed by the bottom curve is the yellow area. So, if you take away from all this area, the yellow area, you get the area enclosed by the two curves. Is that right? Yes. So the area enclosed by the top curve with the x-axis minus the area enclosed by the bottom curve with the x-axis gives you the area enclosed by the two curves. I hope that concept is clear from our example here. Once again, the area enclosed by g of x with the x-axis is this entire area. I hope you can see the motion of my pointer. It's this entire area. The area enclosed by f of x with the x-axis is the area shaded in yellow. So if you take away the yellow area from the entire area, you get the area enclosed by the two curves. That's what the statement means. So, area between the two curves can therefore be written as this definite integral. What does this definite integral gives you? Integral -2 to 2, 2x plus 5 dx represents this whole area enclosed by the top curve with the x-axis. That is this whole area. And take away integral -2 to 2 x squared plus 2x plus 1 dx. That is area enclosed by the bottom curve with the x-axis. This is the yellow part. This is the total area below g of x. Take away the yellow area, and that will be the area enclosed by the two curves. So, what does this give you? Integral -2 to 2, 2x plus 5 dx minus integral -2 to 2, x squared plus x plus 1 dx. That is a measure of the area enclosed by the two curves. Let's work it out. Now, you know how to find these integration. Integral of 2x with respect to x will be 2 times x squared over 2 plus integral 5 dx is 5x. You know how to integrate each term. Now, put this integrated quantity within the limits. So that goes from -2 to 2 minus, let's integrate the second integral. Integral x squared dx is x cubed over 3 plus integral x dx is x squared over 2 plus integral 1 dx is x. And this quantity is within the limits -2 to 2. And what do? Evaluate each of these, put the upper limit first, minus the lower limit, and similarly evaluate the second integral. So here I have that whole thing. This first part is for this. In other words, replace your x by 2 in here. 2 times 2 squared over 2 plus 5 times 2. That is, in here we replaced x by 2. Minus, always put the upper limit, minus, substitute the lower limit. Replace x by negative 2. Alright, so this complete quantity takes care of this integral between negative 2 and 2. Now minus, we have this integral. Now replace x by 2 in here. Gives you 2 cubed over 3 plus 2 squared over 2 plus 2 minus, replace x by negative 2, and there you have. Now remember, this square bracket, the quantity inside the square bracket is this integral. The quantity inside the first square bracket is the first integral. Alright, now simplify this. That will be 4 plus 10 minus 4 minus 10. I don't think that will be a big problem for you. Minus, square bracket, 8 over 3 plus 2 plus 2. That's all right. Minus, negative 2 whole cube is negative 8 over 3 plus 2 minus 2. And that will be, this is 14 minus, this is negative 6 minus square bracket, 8 over 3 plus 4. And what is this? Plus 2, negative 2 goes, minus, minus become positive. So you get 8 over 3 plus 4 is this quantity, plus 8 over 3. Alright, that will be 14 minus negative 6 is 20. Minus 4, that's there, minus 4. And minus, look, see, 8 over 3 plus 8 over 3 is 16 over 3 with the negative sign there. And that gives you 16 minus 16 over 3, and what's that equal to? That is 32 over 3. What does this represent, 32 over 3? This is a measure of the area enclosed by g of x equal to 2x plus 5 and f of x equal to x squared plus x plus 1 between x equal to negative 2 and x equal to 2. Alright, try this on your own one more time, and that's the way to learn. Okay. So area enclosed by the graphs of f of x and g of x from x equal to a to x equal to b, let's generalize it. If this is f of x and that is g of x, this is x equal to a, this is x equal to b, how do you write the general form? It will be integral a to b of the upper function minus the lower function. What all you need to do is integrate the upper function minus the lower function from x equal to a to x equal to b. That will give you the area enclosed by the two graphs. So once again, the area enclosed by f of x and g of x from x equal to a to x equal to b is integral a to b, the upper function minus the lower function with respect to x. Okay, let's try this. Set up a definite integral for the area enclosed by f of x equal to x minus 1 to the power of 3 and g of x equal to x minus 1. Now, I want you to stop the video here and try and graph these two functions. How does the graph of x minus 1 to the power of 3 look like? And how does the area enclosed by these two graphs look like? Try that on your own before coming back and watching the video. Well, here I have the graph of f of x equal to x minus 1 to the power of 3. This is the graph of x minus 1 to the power of 3. You see, it is simply the graph of x cubed translated 1 unit to the right. Is that right? So x minus 1 to the power of 3, and this is the graph of f of x equal to x minus 1. F of x equal to x minus 1 to the power of 3, and g of x equal to x minus 1. So the area enclosed by these two graphs is shaded. Alright, in order to find the enclosed area, we need to find the boundaries. Is that right? Now, how do we find the boundaries? First, we obtain the points of intersection. The boundaries is obtained by finding the points of intersection. How do you find the points of intersection? Points of intersection or values of x where the two functions are equal. So what we need to do is set f of x equal to g of x and solve for x. So we have x minus 1 to the power of 3 equal to x minus 1 and solve for x. Can you do this? Well, what we need to do is take this x minus 1 to the other side. So that will be x minus 1 to the power of 3 minus quantity x minus 1 equal to 0. I hope you understood this. Take that whole quantity to the left-hand side. Become minus quantity x minus 1. Now look at the advantage of writing it like this. Now you have x minus 1 is a common factor. Factor that out. That would be x minus 1 times what is remaining here is x minus 1 to the power of 2 minus 1 equal to 0. And now simplify, or we can set each factor to 0. This is one factor, this is the other factor. So setting x minus 1 equal to 0 gives x equal to 1. That means one point where they will intersect correspond to x equal to 1. X equal to 1, y equal to whatever that is. Now, to find the other points, we set the second factor to 0. This is x equal to 1, where they intersect. Now, x minus 1 to the power of 2 minus 1 equal to 0. Can you solve this one on your own? It's very simple. Take the negative 1 to the right side. That gives you x minus 1 all squared equal to 1, or x minus 1 equal to plus or minus 1. Is that right? If x minus 1 all squared equal to 1, take the square root of both sides. X minus 1 equal to plus or minus 1. Now, that will give you two values of x. What are they? X minus 1 equal to plus 1 will give you x equal to 2. X minus 1 equal to negative 1 will give you x equal to 0. So, you get two values, x equal to 0 and x equal to 2. That tells you that these two function graphs meet at 3 points. Which are the 3 points? Points corresponding to x equal to 0, x equal to 1, and x equal to 2. And look at those. This is x equal to 0. And this is x equal to 1. And this is x equal to 2. And so, how do we now find that area? If you remember the general form we set up, the area enclosed by the graphs of f of x and g of x from x equal to a to x equal to b is integral a to b, the upper function minus the lower function dx. Now, there's a problem here. If you notice, from x equal to 0 to x equal to 1, the upper function is f of x. is this function. The lower function is g of x. But from x equal to 1 to x equal to 2, the upper function is g of x, and the lower function is f of x. That means, in order to find the area enclosed by these two graphs, you need to set up two definite integrals. What are they? It is integral 0 to 1 f of x minus g of x, the upper function minus the lower function, plus, you've got to add it to what? Integral 1 to 2 g of x minus f of x. Is that understood? Okay. So, from x equal to 0 to x equal to 1, f of x is above g of x. Now, this segment of the area is given by what definite integral? This segment of the area from x equal to 0 to x equal to 1 is given by integral 0 to 1 f of x minus g of x. This is f of x, that is g of x. So that is the area there. And that will be integral 0 to 1 f of x is x minus 1 to the power of 3 minus g of x is x minus 1, that quantity with respect to x. Well, you need to now simplify this to integrate that. Alright, you know how to simplify x minus 1 to the power of 3. It is x cubed minus 3x squared plus 3x minus 1. Well, you need to know how to expand a minus b raised to the power of 3. A minus b raised to the power of 3 is a cube minus 3a squared b plus 3b squared a minus b cubed. That's right. Well, you need to apply that. So x minus 1 all to the power of 3 is x cubed minus 3x times 1, 3x squared, plus 3x minus 1. So that's the expansion. Then minus x minus 1, distribute that negative sign. Minus 1, distributing that gives you minus x, minus 1 will be plus 1. Now simplify that again. You have 3x minus x gives you plus 2x, minus 1 and plus 1 cancels. So this is the simplified version of this quantity. Now you can integrate that. What is the integral of x cubed dx? That will be x to the power of 4 over 4 minus 3 times integral of x squared is x cubed over 3, and the 3 on the denominator and the 3 on the numerator will cancel, leaving a simple x cubed. So integrating minus 3x squared gives you minus 3x cubed over 3, that will be minus x cubed, plus integrating 2x gives you 2 times x squared over 2. 2 and 2 will go, that will give you x squared. Alright, now you have integrated and the lower limit is 0, the upper limit is 1. Let's now evaluate it for the limits. How do we do that? First apply the upper limit. So that will be 1/4, that is x to the power of 4 is 1 to the power of 4, that is 1/4. Minus 1 plus 1, that's no problem, and that's equal to 1/4. So this area, which is integral f of x minus g of x from x equal to 0 to x equal to 1 is 1/4. Now, if you look at the symmetry of this, you probably think that yes, this area also looks about the same. But let's find that out. Okay, from x equal to 1 to x equal to 2, g of x is above f of x. So this integral is therefore integral x equal to 1 to x equal to 2 g of x minus f of x dx. Now g of x is x minus 1, f of x is x minus 1 to the power of 3. So that is the area shaded. That will be integral 1 to 2 g of x, x minus 1, minus f of x, x minus 1 to the power of 3 dx. Again, simplify the same way we did last time. That will be x minus 1 without any change, minus expand x minus 1 to the power of 3, x cubed minus 3x squared plus 3x minus 1 dx. And now distribute that negative sign and simplify. That will be negative x cubed plus 3x squared. Watch this again. Distribute that negative. Negative x cubed plus 3x squared minus 3x plus x is minus 2x. See, I combined there. Minus times plus will give you plus 1, and that plus 1 will cancel with the negative 1. So the remaining terms are negative x cubed plus 3x squared minus 2x. Now do this on your own and make sure you understand this. Alright, now let's integrate this. Integral of negative x cubed is negative x to the power of 4 over 4. There you are. Integral of 3x squared with respect to x is 3x cubed over 3, which is plus x cubed. Integral of minus 2x is minus 2 times x squared over 2. 2 and 2 cancels, giving you minus x squared. And the lower limit is 1, the upper limit is 2. Alright, let's find the value of this. Replace x by the upper limit, then minus, replace x by the lower limit. And that will be, replace x by 2, you get this quantity, minus, replace x by 1, you get that. Can you do this now on your own? It doesn't really take a lot of effort. And that will be, if you notice, does that become 0? Try that on your own and see if you get that as 0. Minus, this will be, if you notice, 1 cubed minus 1 squared is 0. So this is negative 1/4 with that negative sign will become 1/4. So this area is also 1/4. So what is the total area? The total area is 1/4 plus 1/4 equal to 1/2. Now I know at least one of you will ask me, but isn't this area below the x-axis and shouldn't that be negative? Now when you measure the area enclosed by two graphs, there is no negative quantity there. You see, negative quantity occurs only when you have a single integral, that is area enclosed by the graph of a function with the x-axis. Then only you have the distinction above or below the x-axis, you have positive or negative. Here we are finding the area enclosed by one graph with that of the other. So both quantities are positive. Okay, let's now look at another one. Sketch the region whose area is given by this definite integral. Integral negative pi by 3 to pi by 3, 2 minus secant x dx. You see, can you read it like this? Integral a to b f of x minus g of x dx. So you can interpret this as the area enclosed by the graphs of f of x equal to 2. What is f of x equal to 2? Y equal to 2. And g of x equal to secant x. Yes, this is actually the area enclosed by the graphs of f of x equal to 2 and g of x equal to secant x from x equal to negative pi by 3 to pi by 3. All right, can you draw these graphs? So I can write this as integral negative pi by 3 to pi by 3 2 dx, that is integral a to b of f of x dx minus integral a to b of g of x dx. This integral is the same as this. Now f of x equal to 2 or y equal to 2. So here I have the graph of f of x equal to 2. Now g of x equal to secant x. How do you draw the graph of secant x? Secant x is 1 over cos x. So you can enter in the calculator y2 equal to cos x. And of course set your scale negative pi by 2 to pi by 2 so that you have the given limits there. So here we have the graph of secant x, g of x equal to secant x. And what is the area that we are interested in? The area enclosed by f of x equal to 2 and g of x equal to secant x. The definite integral represents the area enclosed, and this is the area. That's right. So you must learn how to interpret a definite integral or how to interpret a given area. All right, let's do this one now. Sketch the region bounded by the graphs of f of x equal to 3 minus 2x minus x squared and g of x equal to 0, and find the area of this region. Well, first of all, f of x is this function. G of x equal to 0 means the x-axis. Now, in order to find this area, we need to know the boundaries. X equal to a to x equal to b. How do you find the boundaries? The boundaries are obtained by setting f of x equal to g of x, or set f of x equal to 0 and solve for x. So this is our f of x. And look at the graph of that. I'm sure you can draw that graph and get this result. So this is our f of x. G of x equal to 0 is the x-axis. There you have. And so what we are looking for is the area enclosed by f of x with g of x from x equal to a to x equal to b. We need to find a and b. Find the points of intersection. How? Set f of x equal to g of x. There you go. Can you solve this quadratic equation? Well, you can factor it. Try this. It will be x plus 3 times x minus 1 equal to 0. That will give you x equal to negative 3 and x equal to 1. So, one point of intersection corresponds to x equal to negative 3 and the other point corresponds to x equal to 1. Therefore, we now shade the area between x equal to negative 3 and x equal to 1. The area enclosed by f of x with the x-axis. And write down the definite integral. The area enclosed by f of x and g of x is integral a to b, integral negative 3 to 1, f of x minus g of x dx. Now what is our f of x? F of x is 3 minus 2x minus x squared. Our g of x is 0. So we don't need to worry about g of x. It is 0. So we have integral negative 3 to 1, 3 minus 2x minus x squared dx. Can you do this integration? Integral 3 dx is 3x. Is that right? Integral minus 2x dx is minus 2 times x squared over 2. The 2's will cancel. So that would be minus x squared. integral minus x squared dx will be minus x cubed over 3. Is that right? So that will be 3x minus x squared minus x cubed over 3 from x equal to -3 to x equal to 1. And now replace x by 1 for the upper limit here. Then subtract, replace x by -3. So that will be 3 times 1 minus 1 squared minus 1 cubed over 3. That takes care of the upper limit. Minus 3 times -3 minus -3 squared minus -3 to the power of 3 over 3. That is replacing x by the lower limit, -3. Alright, let's simplify that. That will be 3 minus 1 minus 1/3 minus, that is that negative sign. 3 times -3 is -9. -3 squared is +9. With this negative sign would be -9. And -3 cubed is -27. Divided by 3 is -9. With this negative sign we keep +9. And that makes no problem there. You can see here that will be 3 minus 1 is 2. 2 minus 1/3 plus 9. Is that right? This 9, -9 will go. Minus -9 is +9. And that will be 32 over 3 is this area enclosed by the graphs of f of x and g of x. Well, you must actually practice this. Now, watching the video will not really teach you. You learn it by actually doing it on your own. So close the video now or pause the video and try this on your own. Now, the area enclosed by the graphs of f of x and g of x from x equal to a and x equal to b is, what is that? Integral a to b, upper function minus the lower function. In other words, f of x and g of x are functions of x. Remember, a function of x is generally called y equal to. Is that right? Y equal to x squared minus 3. Y equal to sine x. So you go in the vertical direction. Now, suppose you have functions of y. Now, if functions of x are called y equal to, then functions of y will be called x equal to. Suppose you have x equal to 4y minus 3, x equal to sine y. They are functions of y. If functions of x are upper function and lower function, because the functions of x are expressed in terms of y along the vertical axis, then functions of y will be along the horizontal. Then instead of the upper and lower, you have the right function and the left function. Is that right? Yes. So the area enclosed by the graph of f of y and g of y, two functions of y, from y equal to c to y equal to d, will be integral c to d, the right function minus the left function. The function on the right minus the function on the left. Okay, now let's have a look at that. Suppose this is a function f of y, and the red line is a function g of y. Look at the area enclosed by the graph of that. Now, these two functions meet at y equal to c and y equal to d. So what does the enclosed area gives you? The enclosed area is this, the area enclosed by f of y with g of y from y equal to c to y equal to d is integral c to d f of y minus g of y, the right function minus the left function. Well, let's practice this. Sketch the region bounded by f of y equal to y over square root of 16 minus y squared. Now remember, this can also be written as x equal to y over square root 16 minus y squared. Just the same way we write y equal to x over square root 16 minus x squared. Is that right? So you got f of y equal to this and g of y equal to 0. What is that? What is g of y equal to 0? G of y equal to 0 is the y-axis, or no, g of y equal to 0 is the x-axis. It's the x-axis, which is y equal to 0. So you need to find the area between f of y equal to y over square root 16 minus y squared and gy equal to 0. So your f of y is this, and that can, now we said f of y equal to y over 16 minus x squared is actually the same as x equal to y over 16 minus y squared. I just told you that earlier. In other words, f of x equal to 5x plus 2 is the same as y equal to 5x plus 2. In the same way, f of y equal to y over square root 16 minus y squared is the same as x equal to y over square root 16 minus y squared. Now the problem is, if I want you to graph this function on your calculator, the calculator doesn't have a y variable. It only has an x variable. So what we need to do is, in order to graph this, we need to convert it as a function of x. Then only we can graph it. Now how do you do that? You've got to solve this equation for y. So to graph this, we need to express y as a function of x for solving for y. Now how do you solve an equation like this for y? Alright, watch me how I do that. First of all, I square both sides. Make it easier to get the square root out of the way. Now what does that give you? It'll be x squared equal to y squared divided by 16 minus y squared. You see, if you want to solve for y, because y squared comes in two places, it's going to get multiplied by x squared. If you want to simplify this, it's going to create problems. So what I'm going to do is, I'm going to invert the left-hand side and the right-hand side and see what difference it makes. Look at this. 1 over the left-hand side equal to 1 over the right-hand side. 1 over x squared equal to 1 over the right-hand side means simply flip them over. 16 minus y squared over y squared. What is the advantage? The advantage is I can now split the right-hand side into two parts. 16 minus y squared over y squared is the same as 16 over y squared minus y squared over y squared. Look at that. Now, why did I say this is an advantage? Because y squared over y squared is 1. That means, whereas we had y squared in two places here, which made it difficult for us to solve for y, we are now reducing that y squared to a single place. We can now solve for y easily. So what is this equal to? We have 1 over x squared equal to 16 over y squared minus 1. We need to solve for y, means leave this term here and take that negative 1 to the left side. It'll give you 1 over x squared plus 1 equal to 16 over y squared, or we can write 16 over y squared equal to 1 over x squared plus 1, or 1 plus 1 over x squared. They're all the same. And now let's simplify this. 1 plus 1 over x squared is x squared plus 1 over x squared. And now what do? We can, well, what we can do is we can now solve for y squared. Is that right? If 16 over y squared is this quantity divided by x squared, then y squared equal to, cross multiply, 16 times x squared divided by x squared plus 1. So y squared equal to 16x squared divided by x squared plus 1. And therefore, what is y? Y equal to, there will be two values of y, plus or minus 4x over square root x plus 1. Now, since f of y is given as a positive quantity, we need only the positive value here. So, the positive value is y equal to 4x over x squared plus 1. In other words, the graph of this function is the same as the graph of the positive part of this function. So we will use the positive part to draw the graph. The graph of f of y equal to y over square root 16 minus y squared is actually the same as the graph of y equal to 4x over x squared plus 1. I hope you understood what actually happened. Well, this function is x equal to y over square root 16 minus y squared. But the calculator does not draw that graph. So what we did is we solved that for y and expressed the function as a function of x. All right, let's draw the graph now. This is the graph of y equal to 4x over square root of x plus 1. Now, we need to find the area enclosed by the graph of this function, which is the same as this function, and then g of y equal to 0. G of y equal to 0 is the y-axis. Is that right? There you got it. This is g of y equal to 0. And the line y equal to 3. This is the line y equal to 3. So, look at the area that we need to find. We need to find the area enclosed by the graph of x equal to y over square root 16 minus y squared. Look at the way I read it. In place of f of y, I read it as x. X equal to y over square root 16 minus y squared. That is that graph. F of y equal to 0 means x equal to 0 and y equal to 0. Now that means, what are the boundaries? Now, what is the region bounded by f of y equal to y over square root 16 minus y squared? G of y equal to 0, that is the y-axis, and y equal to 3. This is the area we are looking for. It is the area enclosed by the graph of f of y with the y-axis from y equal to 0 to y equal to 3. That's right. So this is y equal to 0 and that's y equal to 3. That's the area that we're looking for. Alright. So that will be integral 0 to 3 along the y-axis, right function minus the left function. The right function is our f of y. The left function is our g of y equal to 0. So that will be integral 0 to 3 of f of y, y over square root 16 minus y squared dy, minus g of y. I did not write that there because that g of y is 0. Alright, how do you integrate this? If you remember the integration by substitution skill that you developed in Calculus 1, the denominator under the square root you have 16 minus y squared. On the numerator you have y dy. Therefore, you can make an easy substitution that 16 minus y squared equal to u. So we make that substitution, 16 minus y squared equal to u. Now remember, the moment you make a substitution of a quantity, then we need to replace everything else in the integral based on that substitution. So if 16 minus y squared equal to u, what is then y dy in terms of u? Well, all we need to do is find the differential of both sides of the equation. Differential of 16 is 0. The differential of minus y squared is minus 2y dy. Remember that one? Equal to differential of u is du. So minus 2y dy equal to du. Now you need, if you forgot this, you need to go back and polish the skill of substitution. If 16 minus y squared equal to u, take the differential of both sides. Differential of 16 is 0. Differential of minus y squared is minus 2y dy equal to differential of u is du. Now, what this gives you is we can now solve for y dy. That is what we need to replace here. So y dy equal to negative du over 2. There you have. So when this quantity 16 minus y squared becomes u, then the quantity y dy becomes negative du over 2. We also need to deal with the limits. The limits 0 to 3 are given for this y. But because 16 minus y squared has been now replaced by u, we need to replace these limits in terms of u. For example, when y equal to 0, that is this limit, when y equal to 0, u equal to 16. Therefore, in our new integral, when you replace this quantity by u, this limit y equal to 0 become u equal to 16. Let's do that. So use the substitution to rewrite the limits. When y equal to 0, u equal to 16. How about this? When y equal to 3, put y equal to 3 there. It'll be 16 minus 9 equal to u, or when y equal to 3, u equal to 7. Therefore, when you replace 16 minus y squared by this u, and y dy by negative du over 2, the lower limit y equal to 0 becomes u equal to 16, and the upper limit y equal to 3 becomes u equal to 7. So what is the new integral? Integral 0 to 3 y over square root 16 minus y squared dy now becomes integral 16 to 7 of, look at this, negative 1 over 2 square root u du. Did you understand this? If you recall, our y dy is negative du over 2. There you got negative du over 2, and on the denominator you have square root of u. Alright, now this negative 1/2 can be taken out, is that right? There you go. So that negative 1/2 comes out. It'll be integral 16 to 7. If you recall, 1 over square root u. Square root u is u to the power of 1/2. 1 over square root u is u to the power of negative 1/2. So I hope you understood that step. That will be negative 1/2 comes out. Integral 16 to 7, u to the power of negative 1/2 du. And now you can integrate this. Integral u du is u to the power of n plus 1 over n plus 1. So it will be u to the power of negative 1/2 plus 1 over negative 1/2 plus 1. What does that give you? It will be that negative 1/2. U to the power of negative 1/2 plus 1 is positive 1/2. So it will be u to the power of 1/2 divided by 1/2. Well, if you understand your arithmetic, if you divide by 1/2, you are multiplying by 2. So that 2 will go up and cancel with this 2. So what is left here is negative u to the power of 1/2 from 16 to 7. And what all we need to do now is replace u by the upper limit, then minus replace u by the lower limit. So that would be minus. Look at that. That minus is going to stay outside this whole quantity. Replace u by 7. 7 to the power of 1/2 minus 16 to the power of 1/2. Now, if you notice here, this negative makes this positive. 16 to the power of 1/2 is square root 16. That is 4. So negative 4 times negative is positive 4 minus this minus square root of 7. So the area enclosed by the graph of f of y equal to this quantity with g of y equal to 0, from y equal to 0 to y equal to 3 is 4 minus square root of 7. Alright, it's a fairly involved problem, and I want you to go back and try that on your own one more time. Alright, let's try this. Sketch the region bounded by f of x equal to sine 2x and g of x equal to cos x in this boundary. Well, remember, f of x equal to sine 2x and g of x equal to cos x will go on infinitely. Unless we set a boundary, we will not be able to find the area because that's going to be infinite. All right, can you draw the graph of these two functions? Well, here it is. I suggest you draw it from, say, 0 to, say, pi. Is that right? Which comes, this will actually include it there, 0 to pi, or 0 to 2 pi. Now, f of x equal to sine 2x is this graph, and g of x equal to cos x is the other graph, isn't it? F of x equal to sine 2x. Look at the way I'm tracing it out. That is f of x. G of x equal to cos x is this graph. Now, first of all, we need to find the boundaries. Well, we are given x equal to pi by 6 and x equal to 5 pi by 6. But there is actually a point of intersection in between, so we need to find that. To find the point of intersection, what do? Point of intersection occurs where the two functions are equal. So set f of x equal to g of x. And that is going to test your ability to solve trigonometric functions. Is that right? Trigonometric equations. Sine of 2x equal to cos x. Can you solve this? Well, the way to solve this is to write sine 2x in terms of sine x. Now, what's sine 2x? Use the identity. Sine 2x is 2 sine x cos x. So write it like that. Sine 2x is 2 sine x cos x. So that will be 2 sine x cos x equal to cos x. How will you solve it? I know some of you will say divide both sides by cos x. Now, don't you ever do that when you solve an equation, because when you divide both sides by the same quantity, you are taking away a solution which is actually there. You will miss a solution if you do that. So the way to do that is move the cos x to the left side and set the right hand side equal to 0. 2 sine x cos x minus cos x equal to 0. And now you can factor out a cos x. Alright, do that. Factor out a cos x. It is cos x times 2 sine x minus 1 equal to 0. And now set each factor to 0. There are two factors. One is cos x. The other is 2 sine x minus 1. Alright, can you set cos x equal to 0 and tell me what are the values of x? Cos of pi by 2 equal to 0, isn't it? Yes. So that's the only value that is relevant for us. So cos x equal to 0 gives you x equal to pi by 2. We don't need to go further than that. Also, x can be 3 pi by 2, but we don't need it. That is beyond the limit given to us. Well, and we will now set the second factor to 0, and that will be 2 sine x minus 1 equal to 0. You can do that for me, can you? 2 sine x minus 1 equal to 0 means sine x equal to 1/2. And if sine x equal to 1/2, one value of x is pi by 6 and the other value is 5 pi by 6. Sine of pi by 6 is 1/2. Sine of 5 pi by 6 also is 1/2, isn't it? And these are the limits that is given to us. So, if you now look, you have 3 points of intersection. Point corresponding to x equal to pi by 6, point corresponding to x equal to pi by 2, and a point corresponding to x equal to 5 pi by 6. And so, how do you find the enclosed area? Now remember, these are functions of x, which means the upper function minus the lower function. Don't confuse it with functions of y as the right function minus the left function. Here we have the functions of x. So, on pi by 6 to pi by 2, if you take this boundary, f of x is above g of x. Therefore, the area enclosed by f of x with g of x from x equal to pi by 6 to x equal to pi by 2. Can you write that definite integral? Will be integral pi by 6 to pi by 2 f of x minus g of x, which is sine of 2x minus cos x. Alright, can you tell me the integral of sine of 2x dx? What is integral? Integral sine x is negative cos x. Integral sine mx is negative cos mx over m. So integral sine of 2x is negative cos 2x over 2 minus integral cos x dx is sine x. Now don't confuse in here. Now remember, the derivative of sine x is cos x. The derivative of cos x is negative sine x. Therefore, integral of sine x is negative cos x. Integral of sine mx is negative cos mx over m. So integral sine 2x is negative cos 2x over 2 minus integral cos x is sine x. From x equal to pi by 6 to x equal to pi by 2. Now replace the upper limit, x by pi by 2. When you replace x by pi by 2, 2 times pi by 2 will be pi. So this will be cos of pi by 2 minus sine of pi by 2. So negative cos of pi. Hope you understand that. 2x, replace x by pi by 2. Gives you cos pi divided by 2 minus sine pi by 2. That's the upper limit. Minus, now for the lower limit. Negative, that is this negative, cos of, replace x by pi by 6. 2 times pi by 6 is pi by 3. Cos pi by 3 divided by 2 minus sine pi by 6. What is cos pi? You must be able to put that up quickly. Cos pi, remember cos 0 is 1. Cos pi by 2 is 0. Cos pi is negative 1. Cos of 3 pi by 2 is 0. Cos of 2 pi is 1. You must remember that. So this will be negative 1 over 2 with that negative sign become positive 1/2. Minus sine pi by 2 is 1. Minus negative, what is cos of pi by 3? Cos pi by 3. Pi by 3 is 60 degrees. Cos 60 degrees is 1/2. So that will be negative cos pi by 3 is 1/2 divided by 2 minus sine pi by 6, sine 30 is 1/2. Now simplify this. That will be 1/2 minus 1 will be negative 1/2. And this is negative 1/4. And minus become positive 1/2. Negative 1/2, positive 1/2 goes. And that gives you 1/4 is the area enclosed by the graphs of these two functions. Well, what we have done is we have found the area enclosed by f of x and g of x from x equal to pi by 6 to pi by 2. Now we need to find the area from x equal to pi by 2 to 5 pi by 6. I'm sure you can do that on your own. It'll be integral pi by 2 to 5 pi by 6. The upper function is now g of x, cos of x minus sine 2x dx. This doesn't really take a lot of effort now. Integral cos x dx is sine x, and integral sine 2x dx is negative cos 2x over 2. That negative with this negative become positive. And the lower limit is pi by 2, the upper limit is 5 pi by 6. Now, set x equal to 5 pi by 6. Sine of 5 pi by 6 plus cos of 2x. 2 times 5 pi by 6 is 5 pi by 3. Is that right? 5 pi by 6 times 2 is 5 pi by 3 divided by 2. Minus, replace x by pi by 2. Sine of pi by 2 plus cos of, when x equal to pi by 2, 2 times pi by 2 is pi, cos pi divided by 2. And you know the values of this. Sine of 5 pi by 6, do you know the value? That is 1/2. And cos of 5 pi by 3 divided by 2 is 1/4. Minus sine pi by 2 is 1. And cos pi is negative 1, so that gives you negative 1/2. And simplify this, that will give you 1/4 as well. So the total area is 1/4 plus 1/4, that is 1/2. Now actually we have gone through extensively and dealt with the concept of area enclosed by two graphs. I want you to now do a number of these homeworks, or try this on your own. Sketch the region bounded by f of x equal to 0.5x squared plus 2x, and g of x equal to negative x squared plus 2x plus 6. Try this on your own and see whether you understand the concept. All right?